Raoult's law states that the vapor pressure of a solvent above a solution is equal to the vapor pressure of the pure solvent at the same temperature scaled by the mole fraction at the solvent present. Raoult's law is used to study vapor-liquid equilibrium between a liquid and vapor. The equation is YIP equals to XI PI set, where YI is the mole fraction of the component I in vapor phase. XI is the mole fraction of component I in liquid phase. PI set is the vapor pressure of pure species I at the system temperature, where P is the total system pressure.
The bubble point pressure can be calculated by using bubble point calculation. The equation is P is equal to summation of Xi PI set. Xi is the mole fraction of species I in liquid, and PI set is the saturated pressure of species I.
Now we'll be looking at an example which will involve the bubble point calculation. The question is, a liquid mixture contains of N-hexane with a mole fraction of 0.3 and N-octane at 100 degrees Celsius. A. What is the bubble point pressure? B. What is the composition of the N-hexane and N-octane in vapor? Now, let hexane be composition 1 and octane be composition 2. First of all, to find the pressure, we will be using the bubble point calculation in which summation of Xi Pi set is equals to the pressure. In order to get P1 set, we will be using Antoine's equation in which ln P1 set is equals to A minus B over C plus T. In order to get the values of A, B and C, we will be referring to table B2. Now, after substituting the values of A, B and C, we will get P1 set is equals to 1566.132 kilopascal and P2 set as 46.90 kilopascal. One of the precautions that we need to be aware is that the temperature must be converted into Kelvin. Next, the second question requires us to find the composition of N-hexane and N-octane in vapor form. We'll be using the Raoult's law equation in which YIP is equals to XI PI set. In order to calculate YI, we just substitute the pressure and P1 set into the equation in which we already got in the previous equation. Then we will get Y1 is equals to 0.935, and to get Y2 we will just use 1 minus Y1, which is 0.065, as we know that Y1 plus Y2 is equals to 1.
Next, the dew point pressure is calculated by using the formula P is equals to 1 over summation of YI over PI set, whereby YI is the mole fraction of species I in vapor and PI set is the saturated vapor pressure of species I.
Okay, now I'll be talking about the second example, which is a vapor mixture contains of 0.45 mole of acetonitrile and the rest is nitromethane at 80 degrees Celsius. There are two questions. A. What is the dew point pressure? B. What is the composition of the acetonitrile and nitromethane in the liquid form? So A, we need to use the Antoine equation to find the P1 set and the P2 set. P1 set is 95.96 kilopascal and P2 set equals to 50.14 kilopascal. By using the value P equals to 1 over 0.45 over 95.96 plus 0.55 over 50.14. So the dew pressure is 93.86 kilopascal. So then B, we need to use the Raoult's law, which is Y1P equals to X1 P1 set. We will then get X1 equals to 0.45 times by 63.86 over 95.96. We will get the X1 equals to 0.3. To find the X2, we'll just need to do the 1 minus 0.3 and we will get 0.7.
So the first assumption is the vapor phase is an ideal gas. Next is liquid phase is an ideal solution. Thirdly, this only applies to components exist in both liquid and vapor phases, considering T should be less than T critical.
Created using Powtoon.